This is an overview of the multi-file version of CodeWalker. We'll start with a simple example. Here we have a simple inventory system and another file that calls into the inventory system. We're not interested in exactly how either file works, as that's the specialty of CodeWalker's single file view. We will select one of the files in CodeWalker. Also, I've turned on the option to load all files found. CodeWalker will create a graph of every function, and then it will reassemble your code into a code tree, with each level representing a different function or method that calls other functions or methods. You can move around the screen by pressing the arrow keys, or rotate it while holding the Alt key. Use the scroll wheel to zoom in and out. These small trees are functions that do nothing outside of themselves. The larger trees are what we're interested in. These represent the real work going on in your program. The larger they are, the more they're doing. If we open the Filters window and choose the Files option, we can see which files contribute what to each tree. File colors are random and can be changed by clicking the Files button a few times. Additionally, we can trim the display of redundant code, and we can hide all code trees that don't call into other code by clicking the Hide button. Now we have a less cluttered view of what this code does. You can click and drag trees to move them around. If you have the info window open, clicking any layer of a tree will show you what function it represents on what line and in what file. Now we're going to look at a mix of Java and C# files. CodeWalker is multi-language and multi-platform aware through language-specific translators. This means it can work across various types of code and bridge between them on demand. Here we'll use the Files filter again, and we can see that we have multiple files in use and what they do. Let's start by removing redundant data from the display, and let's also remove functions that don't call into other functions. Now we have a pretty clear idea of what this code does and how. Now we can tell exactly how this code calls into different files. We can also find out what parts of the code need to be more optimized based on how often it could potentially run. If you click the heat map filter, you'll see the result of nested loops displayed visually. The more red something appears, the more often it might be used, so you're going to want to look there during optimization. We can also find recursion, whether it's deliberate or accidental, by clicking the recursion filter. This shows a line between the place where the recursion starts and where it ends. If we click the Files button, we can see that in some cases, the recursion actually continues across files. In this case, we're going to just look around for things we might want to fix. Code deprecation is an easy one to look for. Click the Show Deprecation button to identify pieces of code that match Java 6 and Java 7 code deprecation. Code deprecation is indicated by a glowing green letter D. Clicking on those branches will tell us where to look. This tells us that all of the deprecation in this code is occurring in one area. Since deprecation occurs when the authors of a language move to a new design, this helps us identify design patterns in our own code that we may want to look at. So rather than going in and replacing each of these individually, it might make more sense to replace this entire object. If we didn't have CodeWalker, there's a good chance we would just have to replace all of the deprecated code before we could decide what to do with it. As you can see, CodeWalker makes it really easy to learn more about your code, or even code you're unfamiliar with, in a short amount of time. And that's our goal, to help you understand how your code works better, faster, and more easily. If you have any questions or comments, please let us know, and we hope you enjoy CodeWalker.